So, what is an irreducible quadratic expression? Right? A quadratic expression that has real coefficients but no real roots. Okay? Irreducible. It cannot be factored because it will give you imaginary numbers. Alright? There are no real roots. No roots. So, keep this in mind. The polynomial function is of odd degree, meaning the biggest exponent in the polynomial is 3 or 5 or 7. What does that mean? Every polynomial function of an odd degree with real coefficients has... What's the graph look like?
Going down forever, up forever.
Okay, so if it goes up and down forever, can it possibly have no real roots?
Almost really.
It doesn't have to have all real roots. Some, it has to have at least one. It should touch the, because in order for a root to be real, it has to touch the x-axis. Okay? The quadratic doesn't have to touch the x-axis. If it's like a smiley face parabola, it opens upward, and it's like above the x-axis and open upwards. It never touches the x-axis. But if it's odd, it goes up forever and down forever. So at some point, it has to cross the x-axis at least once. All right? All right, here we go. We've been doing this synthetic division to help us find factored forms of polynomials. This is no different. Write f of x, which is a big long polynomial here, as a product of linear and irreducible quadratic factors, each with real coefficients. So, what's a linear factor look like? What's a linear factor look like? Yeah, it's just like an x plus 7, x minus 2 when we factor it. It might look something like this. That's a linear factor. It's a factor that if we were to graph it, looks like a straight line. Okay? So we are going to factor this whole thing. And remember how we start? We're going to kind of divide out until we have this quadratic left. That's what we're going to do. But when I graph this to look where I start, it doesn't look like it crosses any whole number of the roots, does it? It looks like if this goes from 3 to 3, this goes from negative 3, to positive 3. I mean, this is negative 1, and negative 2, and so forth. 1 and 2. This looks like it's somewhere between 0 and 1. Oh, maybe a half. Who knows? Maybe 2/3. And this right here looks like it might be 1.5. So, how can we guess what that is? We'll take the factors of our last term and put them over the factors of our first term. But for the sake of time, why don't we practice and actually use a zero function to figure out what those are? Any guesses on what those numbers might be based on the last term and the first term? We come up with a fraction that's between 0 and 1 here. The products of this are 1 times 16, 2 times 8, and just 4 times 4, right? What are the factors of 3? 1 times 3. Remember, it's the factors of the last over the factors of the first. So can I create a fraction with any of these numbers being in the numerator and any of these numbers being the denominator that might represent this point between 0 and 1? 1/3, 2/3, that's about it, right? So maybe this is 2/3 of that right here that I've circled. Well, that would be in between negative 1 and negative 2. Maybe negative 4/3, which would be negative 1 1/3, right? Only one way to find out for sure. All right, we have a polynomial that's given to us. It's right here in our notes. We're going to type this thing in, and then we're going to use our little bow tie thing to find the 0. Otherwise, we're going to start doing a lot of synthetic division for nothing. Okay? So, here, large screen. It's going to be 3x to the fifth. All right, someone might have to read this to me. Go to y equals. Clear this out. 3x to the fifth. What comes next? Minus 2x to the fourth. Next. 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 Plus 16. Now my window here. Whoa. Oh, good call. That would have messed everything up. They should. I don't understand. Thank God. All right, now my window goes from -3 to 3 on the x-axis, and this on the y-axis, -20 to 50. So let's just make our window that whole thing there. So we'll go from -3 to 3 on the x. Of course, that scale is by 1. And I'm going to go from -20 to 50 on the y-axis, so I can see all up and down. What do you think that scale is? Looking at my graph here. Well, if it goes down to 20, I see 2 tick marks. If it goes up to 50, 1, 2, yeah, about 10. So we're going to wrap this by 10. And there it is in all of its glory. Now, if we want to find the roots, how do we do this again? Seconds? Trace, which is my calc. And I want to calculate what? The 0. So let's start with this one right in the middle, which we were guessing at first. We want to bow tie it. So I want to be to the left of that x-intercept, and then I want to be to the right, which would be right there. Want me to guess? Sure. 0.6666, which is 2/3. We're right. Good. Nice. Good for us. Yeah. So we know this right here is the 0.2/3, which this would be in the numerator, that would be in the denominator, that's 2/3 good. So if I want to check to see if 2/3 works and use synthetic division to start to factor it out, and I say x equals 2/3, all right? And I want to see if it goes into my polynomial with synthetic division, which means I just bring down my coefficients, right? 3, -2, 6, -4, -24, and 16. What do I do? Because there's 2 ways I can do this, remember? I can keep it like this, 2/3, and I would add all my products instead of subtract. Or I can put it in my factored form, then all the products I get I would have to subtract. Well, we said adding is better than, okay, it's better than subtraction, okay? Everybody's writing this down, right? Okay? So, first thing I do is what? Drop the 3. I mean, we've done this so much lately. What is 3 times 2/3? What is 3 times 2/3? This is where you should be quick, especially if what you're multiplying the fraction by is the same as the denominator. If I take 2/3 and multiply it by 3, it's 3/1, yeah, cancel, it's 2. Okay? So I put a 2 up here, and I'm adding everything, right? Because this isn't the factored form. What is -2 and +2? 0. What's 0 times anything? 0. What's 6 plus 0? Okay, what is 6 times 2/3? It is 4. So don't forget, 2/3 times 6, that's 6/1, right? The 3 was in the 6 twice. 2 times 2 is 4. Holy smokes, look at this. Whoop. Yes, 0. 2/3 times 0 is 0. When I add them, I get -24. What is -24 times 2/3? Take a guess. Times -24. It's -16, isn't it? -16, which gives us our 0. That's our remainder. It goes in evenly. Therefore, x minus 2/3 is a factor. Good. Now, what's left? What is the degree of the polynomial I have left now? It's 3x to the fourth. This was x to the fifth. It goes down by 1 every time. This would be a negative 24. This would be my x to the first, right? This would be my x squared, so forth. X to the thirds. This would be my x to the fourth. I want to try and get this so it's x squared. Then I can factor it if I can, right? So, ooh. One more. All right. What's the next one you want to check? We're going to see if this one. Who can tell me using the zero function what that is? Anybody have this graph in their calculator? Or do you want to try this one over here, another positive one? It don't matter to me. Oh, you guys. All right. What do you think this one to the right is going to be? Take a look at our numbers that we have. Remember our factors of 16 and our factors of 3? Yeah, it's actually going to be between 1 and 2. So what fraction can represent between the numbers 1 and 2 with my factors, one of my factors of 16 in the numerator and one of my factors of 3 in the denominator? I think 4/3 is the only one you can do. So it's going to be 1.3333. Let's check it to make sure we're good, and we should be. So I'm going to calculate a 0 again. And this time I got to be to the left of that. That is to the left of my 0. Hit enter. And make my little bow tie. Come back up to the right. Hit enter. 1.41421336. Interesting. Interesting. It's interesting. So what are we missing? What are we missing? I'll pause this here so you guys can talk. Okay. So when we use our fractions, our factor our last number over our first number, what do we get? We get rational zeros, right? This one right here, next to the 2, is irrational. It's irrational. So now I'm going to try this one here. Okay? Who's got that one? Yeah, that one? Yeah, it's irrational. It's 1.414, etc., etc. Yeah, now we're going to try this one right here. It's negative what? Negative 1.4. That's also irrational. So what do we do at this point? Take a look at what we have left. Take a look at what we have left. Let's write what we have left. You guys just told me this would be x to the fourth, right? What do you think? Okay, so this would be 3x to the fourths, right? We don't have any x to the third, so I don't care. I'm not going to write that.
Plus 6x.
Plus 6x squared. We don't have any x's, so I'm not going to even write that. Minus 24 equals 0. Can I factor that? I can divide by 3. If I divide by 3, what do I have left? I have x to the fourth plus 6. Plus 2. Yeah. X squared minus 8. Why am I dividing everything by 2? Equals 0. Can I factor that? I believe so too. I can factor this. Okay? This tells me, right? Let's look over here for one second. Let's say that was x squared plus 2x the first minus 8. What would that be? X minus 2 and x plus 4, right? Do you want to know why? Because this is double whatever this is. When that's the case, we always use the ones, right? The middle exponent. Well, isn't this double what this is? So I can say, I can still do my x minus 2 and my x plus 4. of your square. Because when I FOIL them, wouldn't the first term be x to the fourth? Mm-hmm. So. One of those can be factored, one of them cannot. The second one can what? Can be factored or cannot be factored? The second one cannot be. Because this will give you an imaginary number, wouldn't it? Can't be factored. Can't do that one. This is our irreducible quadratic. That's what the square root of 2 is. 1.414, etc., etc. Isn't that the two roots we had? So that's going to be plus or minus our 1 when we solve that, isn't it? Let's solve for this one. What do we get if I solve for this one? This can't be done. It's imaginary. This would get x squared equals 2. So we get x equals plus or minus radical 2. That's our 1.414 number. That was irrational. So if I were to put that into parentheses, and I'll write it away as to not to confuse you guys, because I don't want to go too fast and start throwing numbers in here. But if I had two answers, wouldn't I have x equals a positive radical 2 and x would equal a negative radical 2? So in here I'd say x equals the sign minus radical 2. Here I'd say x plus a radical 2, wouldn't I? We already have our number above, which we checked. It was x minus 2/3. Wasn't that one of them? That was the first one we did. It was synthetic division, wasn't it? And then we have our irreducible quadratic, x squared plus 4. It has no real roots, because if I were to graph it, that would be a parabola that opens upward and starts at 4 above the x-axis and open upwards. All right. So, possible rational roots are the factor of 2, this 1 over the factor of 1, which is this 1. So we can have 2 over 1 or 1 over 1, positive or negative. And you guys told me that which one of those is a root? 2. So, based on our calculator, we see that x equals 2 as a root. If I use synthetic division and divide 2 into, these are 1s. 1, negative 1, negative 1, negative 2. I get, drop the 1, 2 times 1? 2, my God. If I add that, what do I get? 1. 1, 2 times 1 is? 2. 2, if I add that? 1, 2 times 1 is? 2. 2, if I add that? 0. 0, that's a remainder. This goes in, that is a root, which means x minus 2 is a factor, and what I have left is what? That's right, because these are my x squareds, these are my x's, this is my number without an x. All right? That is irreducible, and how do we know? Yeah, if I graph this clear, I say x squared plus x plus 1. And I will go to my standard window or zoom. I will stick to standard. And graph that. There you go. Never touches the x-axis. It has no real roots. It's irreducible. Which means you have already answered the question. They want it as a factor of linear and an irreducible quadratic. Guess what? This is an irreducible quadratic. This is linear. So I'm just going to say x minus 2. X squared plus x plus 1. There you go. There it is in all of its glory. Not too shabby.